Welcome to Waffle TV. Last time we started with triangles, and of course, we were able to solve the different aspects of a triangle: the base, the height, the hypotenuse. And today we are going to be looking at another aspect of triangles, and this is the Pythagorean theorem. This theorem seeks to establish the relationship between the various sides of a triangle. So by the end of the lesson today, we should be able to state the relationship between the sides of a triangle, as well as we should be able to calculate the base, the height, or the hypotenuse of a triangle. Without waste of time, let's look at this illustration on the board. This is a right triangle. We know that a right triangle has an angle of 90 degrees. The longest side of a triangle is called the hypotenuse. The side below is called the base. You can call it base, and it is the adjacent side. And on this side, we have the height, opposite side. So this is the opposite side, this is the hypotenuse, and this is the adjacent side. Height, base, hypotenuse. We should take special note of this because sometimes they may give you just this term to use and not telling you this is the base or this is the height. If this is understood, then we say this is A, this is B, and the hypotenuse is C. The Pythagorean theorem says that this squared plus this squared, that is the height squared plus the base squared, will give us the hypotenuse squared. And the hypotenuse squared minus the height squared will give us the base squared. As well as, if you subtract base squared from hypotenuse squared, it's going to give us the height squared. So this is the relationship that the Pythagorean theorem seems to establish. What I'm saying is a square plus b square is equal to c square. So let's go into some examples so that we can better understand what to do as far as this formula is concerned and as far as the relationship between these three is concerned. The A aspect says hypotenuse of a triangle, and the rule says hypotenuse square is equal to base square plus height square. In short, we can write it as a square plus b square will give us c square. Let's look at this example together. Our first example says, what is the hypotenuse of a triangle whose base is 3 centimeters and the height is 4 centimeters? This is a representation of it in this shape. This is a right triangle. This is the height or the opposite side, which is 4 centimeters. This is the base or the adjacent side, which is 3 centimeters. And we are asked to find x, which is the hypotenuse. Now let's apply the rule that we've learned here in this to solve. Hypotenuse square is equal to a squared plus b squared. Let us substitute here. Hypotenuse here is x, so we take x square is equal to a square, which is 3 square, plus b square, which is 4 square. This is the same as x square is equal to 3 square is 9 plus 4 square is 16. And this is the same as x square equal to 9 plus 16, which is 25. And to do away with the squared, or to find x, you find the square root of both sides. Here will be x, and x will be equal to square root of 25, which is 5 centimeters. So this is what you can do to find the hypotenuse of this triangle. Let's move to the next aspect, which is how to find the height of a triangle. B, height of a triangle. The rule says height square is equal to hypotenuse square minus base square. We are going to use these same letters that we use in this diagram so that we better understand. If we want to find B, B will be equal to c square minus a square. That is, to find B, you subtract a from c. That's what the rule is saying. Let's look at this example. The second example, calculate the height if the hypotenuse is 20 meters and the base is 12 meters. In this example, what we're going to do is, first we state the rule. The rule is b squared equal to c squared minus a squared. We substitute. B here is x squared because we don't have b. Then our c here is 20 squared equal to 20 squared minus a here is 12 meters. So it's going to be 12 squared. X squared is equal to 20 squared is 400 minus 12 squared is 144. We move to the next step. X squared is equal to 400 minus 144 will give 256. So to solve for x, we simply find the square root of both sides. This will be square root of x squared equal to square root of 256. Here we'll be left with x, which is equal to the square root of 256 is 16 meters. And that is our height in this case. You can prove if it is right by substituting x with 16 and you find the hypotenuse. If it gives you 20, it means your answer is correct. Let's move to the next and the last aspect, which is the base of a triangle. Base of a triangle. What is the rule? We take base squared equal to hypotenuse squared minus height squared. So let's look at this example together to see how you can apply this rule to calculate for the base. If we have a question as such, find the base of a triangle with hypotenuse 10 decimeters and height 6 decimeters. How do we find this base? We simply apply the rule, then calculate, substitute the figures given into this rule and solve. The base, as per this illustration, the base here is A. So we take A equal to, hypotenuse is C, A squared equal to C squared minus B squared. And we're going to substitute A. In this case, we don't know A. So A will be x squared equal to C squared. We already have C, which is 10 squared minus B, which is 6 squared. We move further. X squared equal to 10 squared is 100 minus 6 squared, which is 36. And the next step will be x squared is equal to 100 minus 36 is 64. So to find x, we simply find the square root of x squared and the square root of 64. This will be the same as square root of x squared equal to square root of 64. And x will be equal to square root of 64 is 8 decimeters. So our base in this case is going to be 8 decimeters. Thank you for following up with the lesson of today. In our next lesson, we are going to look at how to find the different aspects of a kite and a rhombus using the Pythagorean Theorem. Until our next lesson, it's goodbye from us.